of a very large project team. The project is taking place within the 5 Southeastern United States research reserves from North Carolina to Florida. So you can see all those logos here. The project team has people from each reserve, as well as a group of people from NOAA.
Did you do any sort of comments there?
And I've bolded the names of the kind of the main project leads in terms of the technical aspects and grant administration and collaboration and things. Oh, here we go. And so because it's a collaborative project, the people who are going to use the information generated by this project are involved from the very beginning. And of course, the NERRs, we are all end users as well. So we're wondering if, if and how we should be using drone technology to monitor our resources. But we're also working with the state agencies that have kind of have a stake in this topic as well. And I've put the names of the people that are kind of our project team end users down there from FWC and DEP, mostly representing kind of the oysters as habitat perspective, as well as Steve Durham's kind of thinking about designing monitoring protocols statewide for the DEP. So we have 4 objectives in the project. First one is to basically use UAS products to measure and model oyster reef characteristics, and I'll go into those parameters later. The second one is to basically compare what the drone measures in terms of those parameters with how we traditionally measure those parameters. So the field-based kind of in situ measurements. The third objective is to see if the UAS products can detect and quantify change over time in these reef metrics. And then fourth, we want to do a comparison of the in situ and UAS methods in terms of cost, effort, and benefit. So sorry, this might be a little fuzzy, but I wanted to kind of just point out where there are opportunities for end user input in this project. Basically, we've all been involved in terms of site and reef selection and experimental design, developing what the primary priority indicators should be, mission planning, image acquisition, and testing out the different workflows that get developed. So back in the spring, we had a big project team and end user meeting, and people voted on the metrics that they thought were most important. And density and size structure came in first, and you can see kind of how they fell out after that. And so we were able to take the first 6 top priorities to measure in the field. So all of these metrics in some way are indicators of reef resilience, persistence, and function. And we're basically trying to get at these using drones, which in the end have the potential to be a lot less destructive and cover more area. So now I wanted to talk through kind of what we've done so far in the project. So far we have done the field work and working on data analysis for these first 2 objectives. And then later I'll talk about the next steps in terms of the last 2 objectives. So in terms of what we did in the field, we used RTK GPS to measure reef height, elevation, and footprint. We used the chain and tape method to estimate rugosity or structural complexity. We used quadrats, of course, to estimate density and size structure of oysters. We also collected and measured the mussels because, at least on our reefs, mussels contribute a lot to the volume and that of the reef. So we included those. And then we also measured the volume of each sample by putting the samples in a bucket and measuring displacement. So in terms of the UAS sampling, we wanted to try to use, well, each project team had a different drone. So it's basically like, you know, in real life, people are going to have different airframes, different sensors. So we wanted to use like what people had. The team decided to time the flights to be at low tide and solar noon, which ended up being logistically really hard to do, especially in Florida and during the summer. But we were all able to do it. The flight paths were flown with overlap at 75% with a ground sampling distance at a centimeter. So that meant that people with different drones were actually flying at different altitudes to get that 1 centimeter. We used ground control points and RTK'd them in. And then not all the time, but in a subset of instances, we flew before and after we did the quadrat excavation, so we could look at the impact of monitoring on the reef, and then also the volume change of the quadrat excavation. And then we're using structure from motion and getting a lot of different orthomosaics, point clouds, DEMs to estimate all these reef metrics. And so you can see here this layout of a typical field campaign. So what we did in the GTM specifically, we started last spring selecting our sites with the help of our Florida stakeholders. And we picked sites based on being able to access them relatively easily, picked areas with some historical data available. And we wanted to be able to see if we could detect impacts to habitat based on things like boat wakes and harvesting. And I'll explain that later. And then we also wanted different reef types. So we wanted to kind of get fringe reefs and patch reefs, and get that variation. So we did all of this last summer. This is a picture of some of our field crew, including the drone, of course, which I named Polly for Parrot. You can see we're stuck on a mud flat at the moment, but we got off. So here are the sites, and the yellow polygons are the drone flight areas, and the orange are kind of the reef itself that we sampled on the ground. So just to kind of show you some pictures of what the reefs look like, this was our marine land reef, and you can see, I hope you can see that it's kind of a flat reef, and it's a really interesting shape. I'm not even sure how you characterize this. It might be a string or something, but kind of a fringe, kind of a patch, and very flat. So there was actually a lot of like shallow subtidal oysters there. Here's the digital surface model that Allix created. And if you can see my cursor, you can see this ridge of higher elevation here with little perpendicular lines. That's the reef. So our second site was Devil's Elbow. It's in the Matanzas River, where there's really extensive intertidal reefs. And we picked 2 reefs that had different exposures to boat wakes. So this one on the top is kind of a nice patch reef, sheltered from boat wakes. You can see how large it is. And then the second reef is right on the edge of the intercoastal. And you can see there's like a ridge of dead shell along the outside of the reef. And some of the shell is really, really packed in from the wave energy. And then our third site was Salt Run. This is a really popular harvest area in our reserve. It's close to the St. Augustine Inlet. Oysters grow really fast here. And so we picked one reef that was in the harvested area and one reef that was in a restricted area. And there's just visibly a big difference between these reefs. Lots of more vertical structure on the non-harvested reef. So we're still working on the imagery processing and coming up with the metrics from the drone from all these reefs. But Alyah, the grad student on this project who's here today, has worked up some of the field data. And so these are from the salt run reefs that are in and out of the harvest area. And you can see that we were able to detect some differences in the size frequency distribution on the non-harvested reef in blue versus the harvested reef in gray. So obviously the reefs that are not harvested have oysters that grow well beyond the fishery size limit. We also looked at number of clusters per meter squared, which is kind of a good indicator of habitat quality, and found much more clustering on the reef that was not harvested. So we'll see kind of if we can detect these same types of differences. Maybe the metrics will be different, but using the drone. So North Carolina, because they're really kind of the technical leads on this project, has already worked up some of their data from the imagery, and I wanted to share with you some of their results. So the first one is rugosity. So on the top here, you have the elevation of the reef, kind of a cross section of the reef that the drone can see. And on the bottom, you have the in situ rugosity that they measured with the chain method versus the digital surface model rugosity. The relationships are okay. You can see that we're underestimating the structural complexity with the drone, it seems like. But you do get the better ground sampling distance you have. So that's the blue line compared to the orange line. So of course, there's going to be trade-offs with how low you fly and how much area you can cover. In terms of the volume of shell, I love these images. These are the quadrats that were excavated, just a 1/16 of a meter. And you can see the volume change and the color differences. And the drone did a pretty good job, R-square of 0.5, and pretty close to a 1-to-1 relationship, comparing the drone estimate to the field-based estimate. So here's density. And what I like about this image is you can see the benefit of using a drone is it's estimating density over the whole reef surface, whereas the field-based estimates are just these little red dots. And they were able to get a pretty good relationship, R-squared of 0.62, between the actual number of oysters counted in the field and what was predicted by their combination of drone metrics. In terms of reef height and elevation, you can see the root mean squared errors here in this graph, and it's looking like the drone is basically getting about 2 to 4 centimeters of accuracy in space. And then the last thing they looked at is footprint. And so they're working on classifying the footprint of the reefs using the visible spectrum imagery as well as the digital elevation model, and getting pretty good accuracy. And you can see kind of the different lines here. The red line is the RTK points of where the subtidal footprint is. And the glare on the water and the tidal stage really seems to impact being able to see those edges. And they were talking about, flying at solar noon actually, helps in terms of looking at the oysters because it reduces the shadows of the oysters that they create on each other, but it causes more glare on the mud flats in the water. So you're kind of looking at trade-offs again. So next steps are to do pretty much what North Carolina has started, refine these workflows that they're producing and start applying that to the data collected at the other reserves. Conduct an experiment to mimic harvest and restoration, which I'll talk a little bit more about. And then eventually maybe develop some kind of reef resilience index using a combination of all these metrics. So in terms of the next two objectives, looking at, can the drones assess change over time? And then how do drones and traditional methods compare? So one thing we want to do is, this is it's only a 2-year grant, so we can't really look at change over time in real time. But we thought that, if we estimate all of these reef metrics using drones, and we can detect differences in space, like from reef to reef, especially in a similar area, then we can infer that over time, if a reef changes, we'll be able to quantify those changes. So the team is really interested in, how much volume change can the drone detect? So yes, we have determined that the drone can detect when we take everything from a quadrat. But in real life, that's not what's happening when reefs are being harvested. People are kind of spreading out over the reef and perhaps culling in place and things like that. So the idea is for us to test that by having some big plots. We're thinking of 25-meter square plots where we go in and we simulate harvest, picking up clusters, breaking off small ones, only keeping the 3-inch, walking around the whole plot, and then having 3 control plots where nobody walks in it or does anything, and then flying before and after that harvest mimic, and seeing if the drone can detect that level of change. And then some of the reserves are talking also about looking at adding shell to reefs in states where they actually do that for management. But I don't think we're going to do that. We're just going to put the shell back after we harvest it. We're going to just sprinkle it back on. And then, talking with our stakeholders in the way that our oysters are managed in Florida, we thought it would be important to see if the drones and the metrics we derive from them can detect change before and after a whole season of harvest. So we want to go back to those reefs in Salt Run and fly them again and see if there's, the difference on the harvested reefs is greater than the difference on the non-harvested reefs over a little less than a year, but, over some time. And then lastly, kind of throughout, we're trying to keep track of how much time it takes people to do things, both with the drone and in the field, all the different costs associated with both methods, and of course the benefits of each one, so that we can make recommendations and kind of provide guidance to people in the future. So in terms of what to expect of like products from this project, we'll have workflows. So kind of detailed step-by-step guidance on how to estimate these reef metrics using drone imagery. So we'll have the models. And then I was thinking and wanted to get y'all's input on, maybe some of this can inform the monitoring and mapping or other guidance products developed by this group. And of course, there'll be presentations and papers. And in the end, we're just hoping, and it's already been happening, this collaboration amongst the states in the Southeast, just even talking about how the oysters are managed and just working more together and learning from each other. Really understanding this new technology's costs and benefits, and hopefully improving our efficiency in managing the oysters. So that's the last slide. I'll pull my camera back over. I don't think anybody chimed in with questions unless they're in the chat, but happy to take them now.
Go ahead, Sandra. It was a great presentation, Nikki. I'm really glad to see that this kind of technology is being used. My grad student has a Margaret Davidson Fellowship through ANO, and she's actually looking at mangroves, going back through the historical aerial footage and taking drone footage and trying to look at the rate of invasion and so forth. But before she did that, I had to use the drone for monitoring our intertidal oyster reefs. And one thing that we looked at was the relationship between cluster size, and our reefs aren't as pretty and dense as yours are. But we looked at cluster size and did the ground truthing, you know, pretty much the same approach as you used. And what we found was a fairly tight relationship between the number of live oysters and the cluster size. Have you, I may have missed it, but I know you were looking at oyster density, but did you actually, were those oysters live oysters? Did you distinguish between live and dead?
Yeah, thanks. Yes, so the samples that we collected from the quadrats, we counted all and measured all the live oysters. So,
Okay.
but we did not count and measure all the dead shell. We didn't, but some of the reserves actually separated live and dead and did the volumes of each of those.
Yeah.
Yeah.
Yeah, we didn't
But
do
I'm
that
curious,
either.
what is your cluster size? What do you mean by that?
It ranged. I mean, our reefs over here, though, it depends where they are, but the clusters, they tend to be more separated than the images that you showed. So we don't get those kind of the contiguous oysters. So our cluster size varied. And I can send you the data. We're about to submit. If my grad student can wrap it up, we're about to submit. So I can share the information with you. I'm happy to see how we did it. But I can't remember the cluster range off the top of my head.
Okay. So she looked at the size of the individual clusters and also counted the live oysters on that particular cluster.
Yeah.
So the bigger the clusters, the more oysters there were.
Yeah, exactly. And you know, we did it a number of different ways, and I think we excluded spat to see if that gave us a closer correlation, and because you know there's so many of them and so tiny. And I should know this because I've been looking at this paper for weeks and weeks now, but I can't remember whether we ended up excluding the spat because they don't contribute much to the volume, but they can, you know, there's lots of live ones. So, but it was actually a nice surprise to see that relationship was quite tight. It was more than 0.6. I think we got up to about 0.8, which is nice.
That's great.
So, yeah. So that's, but I think the scope for using this is remarkable, you know, compared with the trudging around with, you know, quadrats approach. Yeah. So I'm really happy. I mean, our project's small, but I'm really glad to see that you guys are doing it on a larger scale. It's awesome.
Yeah, thank you. It's exciting. Melody?
Yes, thank you. Great presentation. Very exciting to see all this this new innovative work. And I had a question about I think you're still maybe figuring out the cost information, but I was wondering how much it costs to fly a drone per hour. And you mentioned I mean, my question relates to how cost prohibitive is this? Because you mentioned that flying at solar noon reduced shadows, and you got better data for rugosity, maybe. But flying later improved data that you got for another metric. I'm not sure which one. So is it cost prohibitive that you could fly like morning, noon, and evening, or so that's my question.
Oh, good question. Yeah. Well, you know, as you know, it's all dependent on the tides. So you would have to kind of schedule, you would do like your solar noon flight one week, and then maybe your, you know, your dusk or not solar noon flight the next week or something like that, because you would have to try for low tide at each.
Yeah, that makes sense.
So I guess it wouldn't be cost prohibitive. It would just depend on your, obviously, your monitoring objectives and priorities and all of that. But Alex,
do you have a basic some ballpark idea of how much it costs to fly per hour? And I realize there's lots of moving parts to it. You got to get a boat, or well, maybe not always. That you could do some land based. I don't know.
Yeah, we're trying to work through, and I'll let Alex answer for sure, but we're trying to work through how to even do that comparison, because in terms of people time and boat access and stuff, like with the boat, you definitely need a boat when you're doing the field-based metrics. But with the drone, you only sometimes need a boat. You know, it depends on where the reefs are and how you can access by land and stuff like that. So we were thinking about just saying, well, maybe half the time you would need a boat with the drone methods, you know, just as a way to get at it.
Yeah.
And it really depends where you are, but our most of our drone stuff was done using kayaks, because a drone costs about $3,000, you know, with extra batteries and things and the camera. And then it's, well, grad students, so I don't know if they're more or less expensive than techs, actually. It seems to have come out in the wash. But yeah, Jenny would go out with just one helper to put the ground markers down, and she'd go at the winter low tides. So I think the biggest challenge for us was, like Nikki was saying, it's the timing of it. But that's probably true of the quadrat sampling as well. So you know, but the trade-off between the spatial coverage and the detail that you can get with the drone, especially if you back it up with the ground truthing, I think there's still a place for, you know, on the ground, boots on the ground validation, especially, you know, different reefs are different in their amount of, you know, live oysters per unit area, per cluster, whatever. So I think there's still some of that ramp up and validation, but on the whole, my sense was that it was a lot more cost effective than sending, you know, a troop of people out there to spend hours doing quadrats. And there's the destructive aspect of it as well. If you bring stuff back to the lab, if you don't have time in the field with the tides to really process all this information, you have to bring it back to the lab. And then do you replace it and spend time and money putting it back, or is it just gone? You know, so it's not a simple question, but if I had to put money on it, I'd say that the drones are more cost effective. Now, they do require technical skills, you know, the structure from motion, and, you know, the RTK GPS can be a little wonky at times. And then you have to have a drone pilot, and it's got to be FAA approved and all the rest of it. But so, you know, there's work to be done to get to that point. But sorry, Nikki, I didn't mean to hog you. Sorry.
No, you have great really input. Cool. So yeah, great. Alex, did you have anything to add?
Yeah, so the prices of drones have gone up drastically because of the Florida drone rule. So we're looking at, I think we just spent $5,000 on ours. And that's not a very technical airframe. It's a very simplistic system. So I think that's the only difference that I think for Sandra, from I think when you probably purchased, because I know your team is now flying AINER's drone, I believe.
No, we're still flying. Well, here's the thing. So Jenny we were aware of this Florida rule. And so, but Jenny didn't catch it in time. We didn't catch it in time. That's my bad. So she did actually take a post-freeze mangrove survey, which is a really cool data set after that ban came in April, ban on the Chinese drones. And so we were agonizing over this, and it's like, what do we do? Do we use the AINER drone? Yeah, and you know, the platforms, as you said, that are allowed to be used are not as good. And so I contacted our research compliance department, and they hummed and hawed a bit. And what they said was, they came back and said, you can use the DJI footage as long as you don't upload it on an internet connected computer. So I don't know if that's what I was told by the university. It seems like a very easy loophole to me, but so, you know, we're going to beg forgiveness on that one, because the university told me we can do it. So, but that's what they're concerned about. It's not the unit itself, apparently. It's that the data can be hacked if it's connected to the internet. So I don't know what to do with that information, but that's what I was told.
We also did an analysis for a different drone project on a National Science Collaborative transfer of the drone The Swamp to 6 other research reserves, including Aner and Rookery in Florida. And they looked at the cost to rent or purchase, so lease price versus purchasing some of these airframes. So a lease price was for 1 month was $5,250. And that was plus the unknown shipping and deposit. So we were estimating about 7,550 for a lease price, where a purchase price based off of the Florida drone rules and the requirements we have to stick to now, we're looking between 6,300 and $8,000 for a drone. That's just the airframe. So, you know, that's having it in hand and using it indefinite number of times after that 1 month lease. So, you know, you're looking at almost the cost of a drone to rent it for a month. And that was
Yeah.
just the airframe itself. That didn't include certain other parameters like you were discussing with boats and those other additional needs if you were contracting the whole project out.
And the drones don't take much maintenance, at least in our experience. They, you know, they're not, it's not like maintaining a boat that just dies if you look at it funny sometimes. But the drones are they're pretty reliable. You keep the batteries running, you get the spare props, and you don't crash it. And it's yeah, they've been pretty user friendly to us.
Steve, did they answer your question about what the Florida drone rule is? Or do you want more detail?
I think the context clues made me remember. So it's about the the Chinese-made equipment.
Mm-hmm.
Yeah,
Okay,
foreign countries of concern.
I see. Okay. I was also wondering here, like we've talked about a lot of the obvious kind of issues with the tide and things, but I've wondered about how the drones can handle sort of basic variables like wind and stuff like that, like that vary a lot from day to day in the coastal areas. And yeah, have you guys any sense for repeatability of measurements with different, you know, not just light and tide conditions, but kind of weather variables?
So
Alex, go ahead.
we mostly flew on either full sun days with limited cloud, so it wouldn't block out the sun during the flights, or it was overcast, so you didn't have that cloud transition through the sun to create that shadowing effect over the reef. So you have options. Um, and then wind speeds, the airframes can handle quite a bit when it comes to the wind speed. When it's up in the air, it comes down to, are the waves sloshing over that reef from wind direction or the tidal push at the same time? Or, you know, if you're on a boat and you're launching and landing off of that vessel, and the capabilities of the pilot themselves trying to get it on and off the vessel safely without missing the bow. So,
Okay.
so sometimes the drone can handle a lot more than maybe what the pilot is comfortable trying to land the drone on the boat, especially if both are moving at the same time, and the stability of the airframe itself.
So the drones can't, I was kind of imagining that you like pick a flight plan and load it into the drone or something, and it kind of takes care of all of that itself, essentially. Is that?
Yes, that is true. But But for our situation, so we would pre-program a flight, but the boat we were flying off of was aluminum. So it being a metal vessel, it causes interference on the technology inside of the drone. So
Oh, wow.
manually launching and manually landing is a necessity, because you also have to shut off some of the capabilities of the drone to safely get it back on the boat manually. It'll try to avoid either you or the um, other participants in the flight, or other project folks that are standing around the boat, and it will, at least for our situation, um, it wouldn't land sometimes because it was picking up everybody and the boat, and it got super confused.
Oh,
So
interesting.
trying to override those situations. And then, but the flight itself to do the mapping is all pre-programmed. So the flight we did at Salt Run, we will repeat that exact same flight in the springtime using the same exact parameters that we flew last summer. Um, Now, if you're on the shore or in a parking lot, yeah, you can set it on the ground, hit go, it takes off and it comes back and lands relatively close to where it took off from. Because the GPS in them aren't that great.
Mhm.
So that's why I also manually land on a boat, because it might not actually find the boat again.
I
Um,
see. Okay.
yeah, so we had one point when we did our testing, give you an example, launched it. It was having GPS issues because of the metal on the boat, and it decided at mid-flight to create a return to home arbitrarily mid-flight, which means it is somewhere over the river. So if you just let it manually land at that point, you're going to let it land somewhere in the river. So you just have to take over once it's completed its operation and started its return to home, and you override it from there and bring it back manually.
Okay. So, sorry, one more quick follow-up and then I'll shut
Yep.
up. Do you see this as like, are we still really far from ever having like a fully remote? Like, I'm thinking like eventually, could you see having like little drone hangars out on the marsh and then being able to like upload, you know, times and like mapping routes to it and just having it fly out and then send photos remotely or something like that? Kind of like
So that are
a data sound, you know? Where,
Yeah, so that already exists. We just don't use it in our systems. The main users for something like that are uh, agencies that manage solar panels or wind farms, or you know electrical systems. So their systems, they're docks basically, and the drone sits inside the dock, and you can pre-program it for a particular flight at a particular time, and it's connected to a 5G network. And at that flight time and that operation, the dock opens up, the drone comes out, the drone flies your pre-designated flight, it returns back to the dock, begins charging itself and uploading all the data to your network system that you have it connected to.
that's
Um,
awesome. Wow.
so it exists. We had one here at the GTM the other day, and we were launching and landing it directly off of that dock system in the parking lot. Um, so they do already exist. We just don't use them in our systems. Um, and it's to be determined on how weather resistant they are. They say they're weather resistant, but we know that saltwater and marshes seem to eat everything we put out there. So
Right.
um, that's all relative. Like I said, they use them as what we call drone as first responders. So if they're on rooftops in big cities and there's an incident, they can deploy the drone before the resources are even able to be on scene to put eyes on the event unfolding. So yeah, it's a technology. We've had it here, but um, not to the extent that you're thinking of. That's where my brain went when I had them here, and then I
Mhm.
thought about how brutal the tidal systems, and it can't go
Mhm.
underwater. It needs a power source, and it needs a 5G network. So
Right.
some limiting factors, nothing we probably haven't figured out before in our work, just infrastructure.
Right. Well, that's a very exciting possibility.
The airframe we currently have, if we had it connected to a 4G network, we could actually live stream and upload to a designated location if we wanted to, and carry that service. So, but it doesn't have the docking system, so it's not automatic. But yeah,
Right.
and then there's new airframes. So the coastline of Flagler counties, I'm throwing out a random number, say 20 miles long. And there's new airframes that are out there that can launch and land and fly up to 55 miles downrange and take imagery all day long and then come back and land. So they're expanding immensely. It's just, how do we integrate, and at what cost do we want to put out for that integration?
Any other questions?
I just wanted to say, if you leave this meeting today and come up with other questions or ideas or feedback, please get in touch and let me know, because we're open to them.
Thank you, Nikki and Alex and Alyah, for presenting on this today. Very, very interesting, great discussion. I'll send out the recording if folks are comfortable with that. And Nikki dropped a link to the project website in the chat if folks haven't seen that yet. We'll include that in the notes as well. So yeah, if there's no further questions, maybe let's move on. If folks, does anybody else want to take the floor and provide an announcement or update on their project?
Hey, Katie, it's Ann. I'd like to just provide an announcement. I'm working with a committee on the International Conference on Shellfish Restoration that's going to be held in 2024 at Jekyll Island. And we are just, getting the information out. Katie, I'll send you the announcement that you can send out to the entire COP. And stay tuned for announcements for proposals, for presentations that will be coming out, likely from Bose Hancock with TNC. It's September 15th to the 18th. And so if you have that available, hold it on your calendars. And it should be a really great conference.
Thanks, Ann. Anybody else have announcements or a quick update they'd like to share?
Can I just add, Nikki, your presentation, I think would be a great one to have at this conference if it's something that you or your colleagues on it could make. So I'm writing Bose right after your presentation. I was emailing Bose and letting them know about it. And if you could just send me your couple of front slides with the people and the name of the project and everything, that'd be great.
Okay, thanks. Yeah, I'll share that conference with the whole project team. Hopefully at least one of us can get there.
Yeah,